Hi everyone. So today we're kind of kickstarting the second part of chapter 8, which deals with radicals. Okay, and that might sound like something totally new, but just so that you understand, when I say a radical, I'm talking about this symbol right here. What you would probably call the square root symbol, that is a radical. Okay, now we use a generic name, radical, for it instead of just calling it the square root symbol because as you're about to see, there are lots of different types of roots you can take. Okay, but we're just really talking about how to write things in this notation and some of the restrictions on using radicals to represent roots. So this is really a concept that you're already very familiar with. Do you remember when we did rational exponents and we said x to the 1/2? And we always said that's really the same thing as doing the square root of x. Okay, so x to the 1/3 is really the same thing as cube root of x. And some of you sort of already made that connection back in chapter 7. And then the x to the 1/5 would be the 5th root of x. Okay, nothing terribly complicated there. So as a definition, the nth root of x, meaning any root of x you want to take, a 5th root, an 8th root, a 25th root, whatever root you want to take, working with a non-negative real number, so this is saying positive or 0, greater than or equal to 0, your x values are going to be, and then integers for n, meaning your n values should only be whole numbers, okay, thinking about 5th root, 3rd root, things like that. We can always just say x to the power of 1 over something is the same thing as the nth root of x. That's all that definition is really saying. Okay? So we're going to evaluate each one of these not using a calculator. Okay? And again, you're familiar with this because you've done this before. The 4th root of 81, that's really asking you what is 81 to the 1/4 power. Okay? Otherwise known as what to the 4th power makes 81. Okay, that's what you're trying to figure out. You could do this with a factor tree if you didn't know it off the top of your head. Hopefully you know that 3 to the 4th power is 81, so I would say that my overall answer here is 3. The 6th root of 64 in this next example then would be like 64 to the 1/6, which again you could use a factor tree if you really wanted to. You could also think of it as what to the 6th power makes 64. Correct answer there is 2. Okay, so again, all stuff you've seen before. All right, so example 2, approximate each of the following to the nearest 10th. The fact that it's telling me to go to the nearest 10th gives me an indication this is going to be a decimal, meaning I'm not going to be able to do this by hand. I'm going to have to use a calculator here. So let's talk about how to type these into a calculator. If you want to do the 5th root of a number, you're going to start by hitting the 5. And then if you go to the math menu, down here at option number 5, you see that radical symbol with an X up above it. By choosing that, you're really telling your calculator, put that 5 in place of the X. Okay, ignore that bell. Put that 5 in place of the X. Some of the newer calculators will actually put the 5 in that place. But regardless, now we're just going to type in the 4829, and I'm going to the nearest 10th, so that would be 5.5. So cube root of 1990, we're going to go 3, math menu, option number 5, 1990, and I get 12.6. Okay. And that's all there really is to that. So let's keep going. So what about those crazy ones that had other numbers up on the top? Well, remember that we could take this and rewrite it as x to the 1/3 to the 4th power. So based on what we just learned, that x to the 1/3 could be written as a cube root of x, and then you could raise it to the 4th power. Okay, so all you're doing is taking that 4 off and applying it as an exponent. It's also okay if you put that 4 on the inside. It actually does not matter. So you could make it an x to the 4th power on the inside as well. Either one of these would be okay. Okay? So thinking about that, and really I want you thinking almost more about going back the other way. If I gave you this, could you rewrite it this way? If I give you the fourth root of x to the eighth, if you were to write it back as an exponent here, notice the relationship of these two things with the fraction. This is the number up on the top, and this is your root is always going to be the number on the bottom of the fraction. Okay. So this here would really become x to the power of 8 over 4. Here's the top, there's the bottom. And 8 over 4 is really just 2, so that would be x squared. Okay. For the next one, remember to stack them in the right order. This is top and this is bottom. So I would say x to the power of 4 over 12, which reduces to 1/3. And then from here, we just want to pay attention to our directions. Do we want to leave it like that, or do we want to rewrite it back in a radical? This up here says write the result in radical notation. So I want to turn this x to the 1/3 back into a cube root of x. Okay. Now, that next one I know looks crazy. Okay. I'm going to write this out in exponent form. So I'm going to write it out kind of like this. And then you're going to see that this actually works out really easily. And then once you see it once, you probably won't even need to write them like that from there on out. So I'm going to start on the inside, x to the 9th. And then I'm taking a cube root of that, which we know is like a power of 1/3. Just don't get mixed up and think that it's a power of 3. If it's a cube root, it has to be a fraction. It has to be 1/3. Okay? This one without a number, that's just a regular square root, so you have to know to put a 2 in there. Okay? So that would be like a power of 1/2. And then we have a 5th root, so that would be like a power of 1/5. Okay? Now it's just a matter of putting all of these things together by multiplying. So first off, let's remember that that 9 is really a 9 over 1. And then I'm just multiplying all the tops together and all the bottoms together. So this would become x to the power of 9 times 1 times 1 times 1 is just 9. And 1 times 3 times 2 times 5 is, let's see, 6 times 5 is 30. Okay. Let's reduce 9 over 30 to 3 over 10. And then I'm going to put it back as a radical. So I'm going to put the x on the inside. Okay. Remember, the bottom number is what goes out here, and the top number is what goes on the inside as an exponent. And so this right here would be my final answer. Okay. What you may be able to do then is, instead of writing it out this way, really if you just multiply together all of your roots, that would give me 30, which is what I had on the bottom a second ago. And so I could have simplified this to be the 30th root of x to the 9. And from there I could have gone straight to there and then reduced and then put it back in radical form. Okay? But I wanted you to see it written out this way so you would see why I'm allowed to just multiply all those numbers together. Okay? But this can be a shortcut for you. You don't necessarily have to write it out this way, although this is a really good way to do it if you kind of lose track of what you're doing. All right, so let's talk negative numbers, because things get a little bit weird with negative numbers. Which of the following is undefined? We sort of talked about this concept already. But first off, you're never going to have anything undefined when you've got positive numbers underneath. So automatically these two are okay, all right? Because if you have positive numbers underneath, you can do anything you want with positive numbers. It's the negatives that cause us issues. Okay, when you have negative numbers underneath a radical, that can be a problem, all right? Think about, like, for example, square root of negative 64. We know that we can do that with I, right? We can do that with imaginary numbers, but for our purposes, we're going to say that this is undefined, okay? However, the cube root of negative 64 would be okay, because if I had 3 negative 4s, 3 negatives can come back and equal a negative. So this one's okay. I can come up with an answer for this one. It would just be negative 4. This one is where I have an issue, right? Because the sixth root of 64 is supposed to be 2. But if I had 6 negative 2's, that's going to come back and equal a positive 64, not a negative. Okay? So this one here is undefined because it is a negative number with an even root. Sorry, that ended up being much more garbled than I meant for it to be. But it's a negative number with an even root. That's where we run into things being undefined. Negative and even. Okay? Otherwise, you won't have any issues with these, but negatives and evens cause us problems. Okay, so this last example here is kind of a specific example that's getting at a larger concept. And this concept is covered a lot in your next couple of assignments. This question is asked in several different ways. So here's the issue. Normally, we would think that anytime we did a root of something to the same power, that it would just come out to be the original number, okay? And in most cases, that works out just fine. So just as an example, like the cube root of 2 to the third power should just work out to be 2, right? Because 2 to the third is 8, but then the cube root of 8 would bring you back down to the 2. Basically, the root and the power should cancel each other out, okay? But there's a situation where that doesn't happen the way it's supposed to, and that's kind of what this example is getting at. And again, this is covered in your homework assignment in a couple of different ways. So if you look at this example, the fifth root of negative 2 to the fifth, we're expecting that to come out to be negative 2. So let's try it. Negative 2 to the fifth. And by the way, if you need to put this in your calculator, that's fine. Make sure, though, with those negative numbers, that you're always putting them in parentheses. So negative 2 to the fifth is negative 32. So then we're doing the fifth root of negative 32. And the fifth root of negative 32 comes out to be negative 2. That's exactly what we expected it to be. It came back out to the original number. All is good there. Okay? But now let's take a look at this next one. When I do negative 2 to the 8th power, I come up with 256. And then when I do the 8th root of 256, it comes out to positive 2, which is not what we started with, okay? And so the issue really comes back again to this whole negative number and even roots kind of thing. Because I raised this to an even power, it canceled out my negative, and then it made my answer become positive. So this right here only works, it'll work anytime the x is positive, okay? Anytime your x number is positive, this process will work just fine. If x is negative, it'll only work with odd powers and roots, okay? So again, this kind of setup will always work for positive numbers. For negative numbers, it only works when you're working with an odd root and power, okay? Because otherwise your negative sign gets canceled out. So again, I know that seems like a very specific example, but it does come up in your homework assignment several different times. Okay, so that's it for me today. Your homework assignment is posted on the backboard, but it's a couple of lesson masters, 8.4 and 8.7b. This lesson, just so you know, will not be on your quiz on Monday. Okay, this is kind of jumping ahead of the quiz for a minute, but it is not covered in your quiz on Monday. Okay, the quiz will cover lessons 8.1 to 8.3, which are the lesson masters you did yesterday. Okay, have a great weekend.